Okay, guys? So, another 3 subtopics for today, and that'll be enough before you go for your practice. The first is going to be the extremes. Extremely elastic and extremely inelastic, which we call perfectly inelastic and perfectly elastic. So perfectly inelastic demand, okay, where price elasticity of demand is 0. There is no change at all in quantity demanded, whatever is the price. Okay. So how will that look like on a chart? Let's see what are the quantities. Let's see what are the prices. Okay. So basically, at this price, let's say the quantity demanded is this much. At this price, the quantity demanded is the same. And even at this price, the quantity demanded is still the same. So if you connect all of these points, that will give you a vertical demand line or vertical demand curve, so that percentage change in quantity demanded, right? Percentage change in price. As price changes, the quantity people consume stays exactly the same. So the change is 0 in the numerator, making the whole ratio equal to 0 as well, right? Are there better markers? Okay. Right, so the percentage change over here in quantity demanded is always 0. So, is it realistic? In the real world, there aren't many examples like that in the real world. So basically, it's something that you need no matter what, even if it's like, I don't know, 1 million NT per unit of this, we're still gonna get it. So that must be something vital, like, I don't know, water, right? If the water is free, you're gonna have it. If the water is extremely expensive, I guess you're still gonna buy it, right? Because we can't survive without water. So it's not a great example, even in this case, because if water is cheap, maybe you'll use more water, right? If water is expensive, maybe you will use less water. So maybe it's not really vertical line for water, the demand for water, but maybe like nearly quite steep, not exactly vertical, right?
But in the real world, there are always regulators for basic consumption.
Yes, of course. Yes,
resources like water, right?
Of course,
that will
yes,
keep
yes.
the price low.
Affordable. You mean affordable for most? Yes, of course, yes. But I mean, hypothetically, right? I'm trying to think of some examples over here. What could be here? Basically, it's something that you really need, but need in a particular quantity. You don't need too much. So water perhaps is not a great example, because if it's really cheap, you can wash your car with the water. You can wash your body with the water. Or if water is very expensive, you'll only drink it. You'll not use it to wash your car, or perhaps not even the body in the dystopian future, right? So maybe something like vital medicine, right? You can't have too little, you can't have too much, something like that anyway. Perfectly elastic demand, okay? That's where price elasticity of demand is infinitely large, very large number. So demand is kind of a horizontal line like this. So I don't know, what could be an example here? It's kind of hard to think of an example here. Basically, it's something that people very easily like switch away from, right? Let's say, remember we said that elasticity kind of depends on how broadly you define the market, right? So if I put pens here, then perhaps there is some slope in the demand for pens. Once pens become kind of more expensive, maybe people instead are going to use markers markers or pencils, right? But if I define it really, really narrowly, like blue markers, like this one, blue one, not a green one or red or black, right? This particular blue marker is what I'm looking at, right? And let's say originally we start with an example where the price of each is, I don't know, let's say 10 NT, right? And then, let's say blue ones have increased in price. Not much, but let's say only like 12 NT. But if I really don't care which color to use, why would I buy one for 12 when there are others for 10? So even if the price changes a little bit, I'm just not going to buy it at all. So basically here is an example of something that has very close substitutes. These are really, really close to me. I don't really care which one to use as long as you can see it, right? So this is where you don't have any close substitutes and you must have particular quantities, right? Nearly like water, maybe more like medicine, vital medicine, because if you can do without medicine, then it's fine. Here it's something that you don't really need of that particular product. There are a lot of similar things. Okay, so in this case, why is it equal to infinitely large numbers over here? Because percentage change in quantity, right, over the percentage change in price. If the price changes by some number, right, the quantity will drop completely. So this is going to drop by, let's say, 100%, right? If the price change is 10%. Or what if the price change is only 2%? Still nobody's going to buy it because there are so many close substitutes, right? What if the percentage change is a little bit of a percent? Still nobody's going to buy it. Why? If you really don't care which color to use and one of them is a bit more expensive, you just don't buy it. So I can make this number kind of arbitrarily large. So theoretically speaking, although maybe the real world doesn't work in those kind of theoretical ways, theoretically we can call this as large as any infinite number. Okay, I'm going to leave it. So there's that, those are the extremes. Next subtopic is how elasticity changes for a straight line demand curve. So strangely enough, if you look at a simple demand curve like this, let's say, straight line, strangely enough, elasticity changes along, this is along the demand curve. Okay? Let's have a look at some examples. Let's have a demand. Let's call this 100. Let's call this 100, just for simplicity, right? Let's just take some round, similar numbers. So the middle is going to be somewhere around 50, yes? Yeah. And what I'm going to show you is that elasticity of demand somewhere around here is quite different from elasticity of demand somewhere around here. So we're going to take examples here and here. And we'll figure out something about the middle section as well. Okay, so let's take some examples. Let's say the price changes from 75, let's say, to 85, for example, right? In that case, what will be the quantity changes? The quantity changes are going to be from 25 to 15, right? Yeah. Okay, so how much is price elasticity of demand in section A? I'm going to call this section A. Well, that's percentage change in quantity, which is 10 divided by 20, right? That's a negative 50%. Quantity drops over the percentage change in price, which is 10 divided by the middle, which is 80. eighth, I think, is 12.5%. So the whole elasticity is, I think, correct me if I'm wrong, a -4. 50 divided by 12.5, yeah, it is 4, right? Okay, so over here, elasticity is equal to 4. Ignoring the negative sign. How about this section? Let's get some numbers. Any numbers are fine. So let's say 15. Let's say 25 to make calculations easy, because then the middle is 20, right? Oh, then the numbers are also kind of the same over there. That's going to be 85, and that's going to be 75. So just split it. Not split it, I'm sorry. Just rotate it, right? Because now the quantities change from 85 to 75 when the price changes from 15 to 25, right? So let's call this section B. So price elasticity of demand in section B is going to be the quantity decreased by 12.5% when the price increased by a whole 50% from 15 to 25. That's -1/4. So over here, elasticity is equal to 1/4, ignoring the negative sign. So what we'll learn here is that, strangely enough, along the same straight line demand curve, at the bottom part of the demand curve, demand is actually inelastic. And at the upper part of the demand curve, demand is elastic, yes. And actually at the very middle over there, elasticity is equal to -1 or 1, whether you ignore the negative sign or not. So for example, if you have an example like this for that particular demand curve, how much is price elasticity of demand? When price increases, let's say, from, let's say, 45 to 55, and quantity drops from okay, let's have another example, because a lot of numbers are very similar. I'll just draw another one. Price, quantity. Let's call this 200. Let's call this 100. Right? Now, how much is the price elasticity of demand if price increases, let's say, from 190 to, from 90 to 110. And of course, quantity drops then from 55 to 45. How much is the price elasticity of demand in this case? Well, because we've learned that in the very middle, price elasticity of demand is equal to 1, there's a bit of a shortcut. If this midpoint, the average that we divide by, is actually in the very middle of the demand curve, we don't even need to do the calculations. You can double check it, but the answer should be 1 or -1. Oh, what if the question is like this? Price changes from, let's say, $88 to $112. Of course, the corresponding change in quantity would be a drop from 56 to 44. The answer is still 1, because it doesn't matter. The middle is still 100 here and 50 here, right? Right? So whatever are the numbers, as long as the midpoint between those changes is still in the middle of the demand curve, the answer is still going to be the same, a bit of a shortcut. You can double check to do the calculations, or you can do the calculations to do the double checking. I'm confident enough it should be 1 or like -1. So that's the second subtopic. So far so good? Okay, let's turn this so I have more space without erasing much. For the third topic. Which is the total revenue test. So this test will show us how total revenue changes with price changes for two different cases. One with elastic demand, another is with inelastic demand. So let's have a look at two examples. Price changes from 50 to 80. The quantity demanded drops, but only from 120 to 100. Yes, price increase. What happens to total revenue? Total revenue originally is equal to 50 times 120. How much is that? That's 6,000, I think, yes? Okay. And after the price change, total revenue is 80 times 100. Oh, by the way, if you want to take note, I guess it's pretty obvious. Total revenue is price multiplied by quantity, right? If I sell you 3 chairs at the price of 600 NT each, how much is the total revenue that you gave me? Is 1,800, and it's also equal to the total expenditure, because whatever you spend on those 3 chairs is the revenue that I receive, right? It's not the profit, because maybe it costs me to make those 3 chairs. So profit is part of the revenue. Cost plus profit is going to be the revenue. Okay. How much is that? I think it's 8,000. Okay. So as you see, for goods that are inelastic, if you increase the price a lot, people still buy it. It means that you'll make more money, right? So for elastic demand, okay, an increase in price leads to an increase in total revenue, and vice versa. Why? Because total revenue is a multiplication of price times quantity. And if it's elastic, right? I'm sorry, inelastic. Right. First we look at inelastic. If it's inelastic, then the increase in price only leads to a small change in quantity. So this arrow is bigger than this. Total revenue is still higher. This arrow is still bigger than this. Total revenue goes down. Now let's have a look at another example of elastic demand. We had German sausages. Yeah. So 160, 100, 50, and 120, I think we had. So originally total revenue is 100 times 120, which is 12,000. Yes. And total revenue after the new price change is 160 times 50, which is only 8,000. Right? So you see total revenue drop in this case with a higher price. Why? Because if the product is elastic, or not the product is elastic, if the demand for the product is elastic, you increase the price, trying to get more money from the customers, but they just don't buy your product because they buy other things. So for elastic demand, right, as price goes up, total revenue drops. Why? Because since it's elastic, an increase in price brings a bigger drop in quantity, right? And vice versa, a decrease in price leads to an increase in total revenue. Why? Because total revenue is the multiplication between price and quantity, right? So if I put quantity here, if it's elastic, a drop in price brings even bigger change in quantity demand. And hence the test, right? Kind of more applicable to the real world. What we've talked about so far is more like theory, right? Maybe important for those who want to go for master's degree later on, for higher postgraduate degrees, you gotta know the theory, right? But for those of you who are gonna run your own business in future, trying to sell shoes or other kind of apparel or sell your services online, whatever, why do you need to learn all of this theory, calculations? Well, perhaps this is a bit more applicable, right? Because in class it's easy, I give you the demand function. We can do calculations on that. But if you sell your actual product, you design really nice shirts, you sell them, people buy them, they order them online from all over the world, right? What's actual demand curve for your shirts? Nobody's gonna just give it to you, right? Maybe you want to make your own tests. Change the prices a little bit, see what happens to total revenue, right? Is it decreasing or increasing? That can tell you something about the demand for your product. You drop the price of t-shirts, are you gonna make more money or less? Let's say you drop the price of t-shirts and you make less money. How do you guys think? Your demand for t-shirts, is it elastic or inelastic? You drop the price of t-shirts and you make less money. Inelastic, yeah. So you drop the price of t-shirts and you make less money, right? So same amount of people, more or less, are buying your t-shirts, so you didn't manage to attract more customers, right? But the t-shirts are now cheaper, so you're making less money. Or vice versa, if you, let's say, increase the price of t-shirts and you make less money, what does it tell you about the demand for product for your t-shirts, right? Is it elastic or inelastic?
Elastic.
It's elastic. We are over here, right? So yeah, and of course all of that is then you can make some decisions actually related to your business. It would be nicer if the demand for your t-shirts is inelastic, then you can generate greater revenue by hiking the price, increasing the price. And then it depends on how you position your company, how you differentiate from other t-shirts. Oh, my t-shirts are so amazing, they're not like that other t-shirt because something, and you're gonna have a campaign on that, I don't know, right? So there it is. Last 3 topics for this part of the class. Questions? The Moodle slides also talk about total expenditure test. It's exactly the same, because total expenditure is the same as total revenue. Because if I sell you 3 chairs, your expenditure on 3 chairs is 180 NT, if each chair is 60 NT, let's say, right? My total revenue from those chairs is the same. Right? So there are 2 tests kind of described in the slides. Any questions? Let's go for the test.